Hello. Let's use this minikube and a job spec to create some jobs. All right. So let's first just testing all this out, and I'm going to go ahead and power off this box because our quota increase, I believe, has come in, and I can go ahead and increase the CPUs on this box up to 64. So if you're just joining, what we're doing right now is we have to classify some audio. We've built a model, we've trained the model, and now we need to go ahead and use this model to classify all of our audio files that we've started with to see which ones actually match up with the model. We have a lot of files to go through, so we're containerizing this process. We're using Kubernetes and Docker to, in the job spec on Kubernetes, to create multiple instances of this container running, so that way we can parallelize the classification process. And we have 105 classes, so we are splitting this up across 105 jobs. We're not going to run all 105 at once. As long as this request went through, and I can up this to 64 now. Let's find out. Then we'll set our parallelism to 64 and allow 64 containers to be running at one time. So yeah, we have an Ubuntu image up, 1804. We've installed minikube on it, and we have this Docker file that we've created that pretty much just installs the libraries for our Python script and creates a few folders. One thing to note here is we need to update that script to delete the files. Before we had this worked. We had a local data storage place that we were using. Originally we were using Docker to run this, and it was just attaching the volume to the local hard drive. But this time we're running it inside of minikube, so it's just in a small pod, and that has a limited amount of storage. So we're going to update our script so that way it deletes the audio files whenever it's done with them. Just cycle through them. Let's see, what else are we going to do here? What else are we going to do? I think it might be about it. I think we might be about ready to go through this. So as soon as this instance boots up, I will show you just a few different things. We have Redis running. We have a Redis server service. Redis server service. Running on Kubernetes, and that's what the Python scripts are talking to. So pretty much Python script is going to launch. It's going to ask Redis for the next available job. It's going to take it, do it, storing its output in Redis, until it's done, and then it will shut down, and the next one will boot up. Right. So we're going to have 105 successful script processes, 105 completions. Whenever this thing boots up. We're getting there. Alright, I'm just going to go and close everything to the right of here. So the job spec for Kubernetes is really cool because it, as opposed to the other specs which are expecting the container to keep running, this one you can set for a single completion of a container or a pod. And you can also set the parallelism, so how many you have running at one time. So it's very convenient, especially for tasks like this where we want to run this one data process and be able to scale it up, right? Like that's why I ended up going with minikube here instead of running Docker run, which is what I was going to do. Because we could just do that. We could run a for loop in bash for like a sequence 0 to 105, pass in that number and go through them all. But what are we going to do later on when we have 500 or 1,000 birds? When we have more processes than we can run on one machine, we're going to set up a cluster for that. And then, cool, succeeded. So we just went ahead and created it this way so that way it would be nice and scalable. Alright, so we're going to log into this. I just need to edit the script to remove the audio files. Otherwise the pod's going to probably run out of space while it's running. Then we should be good to go. So this is our classifier again. You've seen it. I'm just going to go through it real quick to show you. OS, SH, util, redis, and JSON. NumPy, TensorFlow. This is our Nayuki fast Fourier transform library that we're using to create the spectrograms. Some basic information like we're using a 16K for the sample rate. Our NFFT is 1024, and we're taking 512 chunks and skipping by 256. So max files here we set to 10. I'm gonna go ahead and change this to 50. And then later on, alright, so here we're downloading the wave. Creating the spectrogram from it, which is just going over in NFFT or half NFFT chunks and grabbing that data and performing the transform on it and just stacking it all up. So we also could take the log of it, remove any negative or infinity values, and divide it by its own means. That way it's all standardized. You know, some mics are louder than others. So what are we looking for here? What are we looking for? It's when we are done with downloading the wave, hset, then I want to remove this file. So os.unlink. Yep, os.unlink audio. There. So we'll remove the file there. So MP3, actually. This is going to go here. We'll remove the MP3 as soon as we're done with it. And then down here, we remove the wave. Okay. One more file to edit. Weird. Wonder what I just did there. That, we have the unlink in there, that there. Oh no. We'll find out. Oh, that's missing a parentheses, and I bet you then that one is too. Oh, that's what it was. I had this other file here. Well, whatever. Build, remove. We don't want to start the job yet. For right now, we're just going to build this container. Actually, before we do that too, let's take care of a few housekeeping items. We have to mount our data drive. And so here I'm just I'm removing the Docker directory, which sounds kind of crazy, right? Moving Docker. What are you doing? The drive for the main partition here is only 25 gigs. I didn't take into account container size when I was doing this originally. But I have a data drive, so I'm just mounting the data drive to the Docker lib directory. Now, We start Docker. I go back to that build. Actually, hold on. There's one more command I need to run. There it is. Weird. It's also weird. That's what it is. I haven't started minikube yet. Minikube start. And then we're going to run that other command, which attaches minikube to the local Docker instance, or allows them to share an environment so that way you can build a local container and then launch it. This is the first time I've ever really used minikube. It's really nice, and I might need to switch this over Docker Compose because, well, it matches what I would use in production, right? So you want to kind of stick with that. Next thing we're doing now is building that, and that's a lot more expected because we've already ran this earlier, and so it should be cached. So we need to do one other thing, and let's get that URL. It's going to say, oh, hold on. Really? Okay. So our job was still running, which is kind of cool. You know, I turned off this box, turned it back on. Now with all these processors, look at those. It's a lot of processors. Okay, so let's update this job spec to see if we can get it to run everything that we want. Oh, you know what? Just remembered one other thing we forgot. That max files. I never actually added that in there. And that's going to go where? Audio files here. We've set up there. Okay, max files. Cool. One more build. Alright, we already deleted that job, right? Boom. So when we run this, we actually want 105 completions. Parallelism is 64. Back off limit. Alright. 4. Doesn't really matter here. Let me get that URL again. For redis. Okay. And I want that because import redis. R equals redis dot redis 192. Where's it at? I just copied it, but 192.168.59.2 port equals 30400. Baby equals upset. It's nap time. Okay, r dot is it get all? I probably have it here in the history. Get tasks. Okay. That's what I was looking for. R.get. Okay. Operation against key holding the wrong type of value. That's weird. Okay. I can do ln though, can't I? Cool. So what have we done? We just went through and created a list in Redis and added 105 classes there. All right, 0 through 104. And we updated our job spec. I make sure I've built the most recent here again. Boom. Did the job to do that. Boom. Okay, so now let's see what happens when we do cube ctl apply -f job. Look at all those pods. Look at all those pods. Isn't that pretty? Top's got a lot of things going. Top's got a lot of things going. Cool. All right. Describing classy. Creating pod. So let's just look at the logs of this. Cannot load dynamic library. I would have thought more logs would come out, but I guess that's... 64 running, 0 succeeded, 0 failed. Well, everything's pretty idle right now, isn't it? Like we have processes going, but kind of idle. What are we waiting on? Isn't it so many started at once and it got upset? That could easily be the case. Like everything queried redis at the same time. Speaking of, let's go back into Python 3. So there's still 105 on there, so nothing's grabbing anything yet. That's weird. Moved along a little bit. You know what I should do next time is let's go ahead and add this in there. Do we have time? Yeah, we haven't imported time. OPQRST. Yeah, I alphabetize my imports. You don't? It's kind of weird. You should. Alphabetize them, group them, do something weird. I don't have NumPy in here, or do I have NumPy? Math, square root, NumPy, I do. Sweet. 10 times. I think I'd have that right? Python 3. NumPy as np, np.random.rand. Okay. Just wanted to make sure it gave me back a single number and not an array. How are our logs doing? We have things going on? Do we have things going on? What's going on, Box? What's going on? Alright, so it's going. Gotta read what I'm doing. There we go. We're down to 41 left to go. That's cool. R dot, was it H get? Something like that. And all. There we go. And asset classes are coming in. Kind of would have expected them to look a little different than that. But I guess if there's only one, I guess of all these so far, I've only done one. And each of these assets only has one class. I just would have expected. There we go. They are getting comma separated. Cool. So it's running. We have not heavy usage yet. If you wanted to see a graph of it, I wonder if we could see a graph here. 4%. Not much. Maybe it's going to keep getting going though. We'll come back and check in a little bit. So I've been running into this issue with minikube. Even running all of these containers at once, it wasn't using up enough resources. I couldn't figure out why. Come to find out, I guess I closed the page that had it. But yeah, I need to start minikube with more CPUs and more memory, because it has its allotment whenever it starts up. Sorry. I'd ran sudo because I've been trying to get this to work, and it was telling me there was an error. Turns out the error, I was requesting too much memory. This box is a nice size 64 core box, has 200 plus gigs of memory, but I was requesting like 247 and it has 241. Anyway, minikube starting now. After this starts up, we're going to attach minikube to the Docker environment. That's going to allow us to run, here we go, to use local containers. So right, I can come back over here to build. I can build our container again. We're going to call it classy. And because I'm starting minikube from scratch, it has to build all of this from scratch. So this takes a few minutes. I'll probably cut the video and come back here. Okay, so classy's running. Look at that. Before we were only getting like 6% CPU usage. What have we got now? Oh, look at that. We got half of our CPUs being used. How pretty is that? All that data processing. All right. So let's go ahead and ramp it up a little bit more. Can we run all 64? Let's run 62. And so we leave just a little bit for redis, right? Okay. So we got more going now. And what have we got? Idle. Idle 3%. 6%. I mean, that's just, it's nice. All that data processing right now. I've been trying to do this for a little while now. And like I said, I kept running into this minikube issue to where by default it uses like 4 gigs of memory and 2 cores, which was hindering our efforts here. But this is all working. Check us out. We go to Python 3, pull in, where's redis? Redis. And one more time, that. And if we also import JSON, and we got this command here, we just saved more of our data. Really, I bet you I could instead of using A there, just use that command. Okay. I wrote it to the wrong place. There we go. Almost there, guys. Everyone, people, anybody watching this. Webcam. Hello, webcam. So, we got all that going. Can I do that? 619. So if we do that right there, that right there, and that right there, it's increasing. 674. See, this is running really, really well. Crazy. Anyway. So, that is that's the job spec in Kubernetes that can run containers and not have to restart them. It expects completions, expects the container to start up, do some stuff, end. And you can control how many completions, you can control the parallelism with it. So how many are running at once, and you can control your resources. Now you do have to change a couple things when doing this. For example, I had to set up a redis server so that way they could all talk to each other and there were not collisions of 64 containers, 62 containers coming on at once, all trying to be like, hey, let's read this file to figure out what we're supposed to do, and they all do it at the same time. Redis is made for that type of activity. So that's why we have it running here. However, it doesn't actually store stuff to the data, to the hard drive that often, so every now and then right here, we're going to just go ahead and keep writing it to the hard drive. I'm going to go and switch to 3 just in case, you know, if it dumps out, then I don't want to be overwriting my files. So if we needed to scale this up, we could create a cluster of 400 different servers, run Kubernetes on all of them, push this out there and have it run through 200,000 jobs at one time. And it would not take much effort from here other than those quota increases, as you've seen from those other videos that we been running into. So yeah. The job spec on Kubernetes is pretty cool, especially when you compare it with TensorFlow. And TensorFlow is pretty cool whenever you compare it with Docker and containers. It just makes the development of everything a lot easier. So this is going to keep running. Maybe we'll come back in a little while and see how this actually matches up with the rest of our files. Hey, I figured I'd follow this up with just a little bit more here, because I'm still waiting on everything to process. So I'm running this r.lin command, pretty much getting the length of that list that's still processing, and doing that to see how everything's going. Hey, I am in the screen, so let's keep that Python instance running, and we'll come over here and look at the pods that are running. kubectl get pods. We can see everything running, and we can see some completed instances. That's what's really cool. All right, so it's ran, all done, and we can even look at kubectl describe job classy. Here's our classy job. Our parallelism is set at 62. Our completions are set at 105. And we see pod statuses. We have 62 running, 4 succeeded, and 0 have failed. How nice is that to look at that? You can modify it. You can't change the completions or the, yeah, you can't change that number while it's running, but you can change it and run it again. You just have all that data right there. It's a nice deployment. Anyway, and this is all on minikube, running on one computer. What else can we look at here? Let's go back to that. Python script. And we got 38 classes left to write. Let's go ahead and dump out our data one more time. And how much data do we have right now? Let's see. Oh. All we're doing right there is, hgetAll is querying the asset class hash in Redis, and then we're dumping it out to this file out.for.json, wrapping it in json.dump, so it's all JSON. Hello. And then AC equals json.load, loading that file exactly right back up. And then I wanted to come here and count the length of it. So we've counted 1,498 assets. It's kind of cool. Got 35 left to roll through. I don't know if there are any errors. Looks like none yet. 9 succeeded, 0 failed. And as long as we save all of our output data and reload it before next time, even if we ran this again, it should just go through real quick. But we have limited it here to 50 files for each class, which if we increase that, if we actually wanted to go through and get all of the training data that we could, then we have to increase that a bit more. I think I have like 1,000 files for some of these. So we have to look at that. Where are we at now? 62 and 12, and none have failed. Minikube is really easy to install. You can go and just Google it, and there's like a minikube.io site. Just remember whenever you're running the start command to include the -- memory and -- CPUs. That way you can actually take advantage of whatever resources you have in your box. Okay, yeah, this is the installation instructions for that. I don't know what else more really to go over, other than if we look at this YAML file again here, I can just show you again, like, I just search for the YAML spec and copy it, right? We've named our container here. This really could be named anything. But the image is classy because it has to match the image that Docker built and tagged as classy. Yeah, you can see how many times we're running it. This back off limit, I think if it tried to pull it, I would try up to 4 times to pull it and then stop. It's not really relevant here. Like I said, I copy and pasted this and filled in my values, and well, that's the previous student's homework. Now here's our Redis selector, our Redis service that has selectors for pods. See, selector right there. Anything that has the app of Redis, and so this deployment, it adds the label app Redis, and so that's what allows everything to grab it, right? Or maybe it's that, or maybe it's that. Not really. That's just how they're all linked up, right? You have these selectors and labels. Yeah, we're running this Redis image 6.2.0. And we have this container port with node port enabled. Where's node port at? Right up here. This is in there by default, but added it as well. And then that, as well as that little URL command, minikube service -- URL Redis. So that shows us the Redis URL that we can use over here in Python to connect to it. Speaking of, we have 4 classes left to be running. Now this is just moving along. Let's go ahead and save that data again. JSON dump out to 5. I'll load up 5 and count 5. 2,252 assets that we've gone through. Some being multiple predictions. We've also limited all of that to the 2 minutes of audio at the beginning of it. So one question I've continually faced here is, what do you do with those long audio files? The idea is that if an audio file is shorter, that someone was probably more deliberate in taking it and labeling it versus one that's just been on and like, oh, I heard this bird during this span of 5 to 8 minutes. So that's some of the logic behind limiting the audio files to 120 seconds. Limiting it to 50 files per class. I'm not sure what to do there. I'll be curious what the scores for the assets that are in the range 11 through 50, because during training we used assets 1 through 10. So we'll see. Wow, 50 succeeded, 55 running. Yeah, we'll see if how much it memorized those 10 and how well it did on all the other classes that it could do. So maybe we'll look at that next. So this job is just still going. It's been going for 13 minutes now. At least the pods that are open have been going for 13 minutes. How long has the total thing been running for? Start time at 19:14. 19:29, so what's that, 15 minutes? Not bad. Not bad. I guess this is in chronological order because in 3 minutes those started up. Okay, one more time. Let's just look through everything. Here's our description of it. 47 running, 58 succeeded. So we're really getting there. Let's go ahead and save these again. Save it, load it, and count it. 2,707 assets that we've gone through. Okay, and it's scalable. In the Docker file here, the reason that I have these make directory commands, a lot of it's just left over from whenever this was running as just a Docker service or a Docker container locally instead of with minikube. I was attaching the volumes from my local drive. One was for scores. We can probably delete that, as well as audio. No, audio needs to be used, and app needs to be used, because those are used by the script that's running. Anyway, the reason I have the 1,000 and 1,000 in here, and I never actually switch over to user 1,000. I've missed that all along. I wonder if anybody's been watching this and been annoyed at that. Actually make it 1,000. So this just creates those folders, assigns it to user 1,000, and then runs everything as user 1,000. And the purpose of that is so that way anything that was volume mounted to your local system will have at least the 1,000 user ID, which is probably yours. Okay, we done yet? 41 running. So it'll probably keep going for a little bit. Oh, that's my notebook container or screen. Just trying to figure that out. Okay, Job, YAML, redis. We've gone over all these. Classifier. I wonder if any actually spit out that already exists continuing. None there. And none there. Weird. There we go. We're still running down to just 34. 71 complete. So what else should we look at here? Go over and save our data in Python again. As file 7. File 7 and count. File 7, 3,200. Cool. Cool. All right. 25. So at this rate, they'll be done in what, like 4 minutes? There could easily be one on there that just has a lot of data, like it has all 50 files, and all 50 files are at least 120 seconds, and so it's doing a lot of spectrograms. Maybe. Sorry, I'm tired. You know, it's been a week, and it's Tuesday. 18 running. Just happy this is finally working. Yeah, I've been working on this one for like 2 hours today because it kept running into silly issues, like, I don't know, running into CPU quotas, and 14 left. Minikube not scaling up. Trying to get a minikube container to actually access the local host IP of the host box. That was fun. The answer there was I start a minikube service and I just use it inside of the pods, inside of minikube instead of outside. So in other words, I just gave up. Besides, this way is a lot more scalable anyway. Yeah, because if you're running, if you're running this again for like 200,000 jobs, and you would have like, what, 15 Redis servers that would all be working together, and those would all be a service. Down to 9. Seven. 6. 5. So I'll try to put some information for these useful commands in the description. Docker's cool. Kubernetes is cool. It's very useful. It allows you to be quick with your deployments and with your just from data processing. The Ingress controller and also certbot are really cool because it will automatically pull like Let's Encrypt SSL certs for you. So you can take an entire deployment down to a makefile, like a Helm chart. It's just the different YAML files for a deployment. Like you can run like Helm creates, and it will create a little chart for you, and you could wrap all this up in that package. It's nice. 1 remaining. A little container that could. Keep coming. If you're still watching this, you're a trooper. I don't know why you're still watching. I don't really know why I'm still recording, other than like I've been recording all day long trying to get used to making these videos. Because there aren't enough videos for topics like this. Like I've been trying to find some stuff on using attention in Keras, and it's freaking difficult. Come on now. Boom. Oh, there we go. As soon as I set up the watch. See that? Everything's done. Job completed. Let's save our data one more time here. And we're actually going to call it scores.json. Alright. That should be it. Let's check and see how many scores we have here. Come on now. AC. 3,500. Alright. So, I'm going to go ahead and turn off this box for now. Alright, I can do that. This is all done. Scale it back down. and we'll come back in a little while. Oh, power of. Okay, and we'll come back in a little while and actually use those scores and whittle down the training data so that way we can use smaller spectrograms. Instead of 15 seconds, we'll use like 5. So.